In this video, we are going to go over something very, very rad. We are going to go over how to find the rate of change. We're going to talk about also why it makes sense that we call it the rate of change to help you to remember what rate of change means so that when you see the instructions, find the rate of change, you'll know what to do. Let's jump into this. So the rate of change is actually something that you have done before if you've watched previous videos on finding patterns in data. If you haven't, that might be something to check out. But if you have, this is a great connection to something we've done before. So what we're essentially doing when we're finding the rate of change is we're doing exactly what this expression tells us. We're finding the rate, which is the comparison of two numbers with division. Okay, rate is comparison of two different, I should say quantities, or two different numbers by division. And we're comparing by division changes or subtractions or differences of things. So division of differences, that's literally what rate of change can translate to. What differences are we talking about? Well, we're going to look at the comparison of two different quantities, in this case, time and distance. So here, let's say that we want to look at how time is changing. That would be the change part. How much do we change from 0 to 1? We go up by 1. So how do we figure out how much we go up by? You're literally doing 1 minus 0 is 1. 2 minus 1 gets you the total change here. Or we go up 1 from 1 to 2. How much do we change from 2 to 3? 3 minus 2, again, is 1. And then how much do we change from 3 to 4? 4 minus 3 is 1. That gives you your change. We are now going to do the same thing for the distances. Looking here, we go up by 20. How do I know that? Because 20 minus 0 is 20. Very sweet. How much do we go from 20 to 40? 40 minus 20 is 20. Beautiful. From 40 to 60, we go up again by 20. So we go up by the same amount, or 60 minus 40. 80 minus 60, which will give us the change from 60 to 80, is again 20. So now that concludes finding the changes in each of our values. The changes in time, we go up by 1 each time. The changes in distance, we go up by 20. So now we're going to change this into more pattern speak. Basically, for every 1 second or hour or whatever unit of measurement we're using, for every 1 that we go up in time, we go up 20 in distance, or 20 in distance for each 1 in time. That's the rate. 20 plus 20 for every 1. And that is your rate of change. So if it's like miles and this would be hours, your rate of change would be 20 miles for every 1 hour would be your units. Isn't that sweet? That's it. That's the rate of change. Now, overall, some teachers will teach it slightly differently. They might, instead of looking at the differences this way, actually ask you to do a subtraction problem. Meaning, let's just look at we can just find the rate of change between any points since it's the same throughout. So I'm going to pick 360 and 480. We would find the difference between 80 and 60. That would give us the change in distance. So that would be 80 minus 60. That would be the change in distance over, because we're finding a rate, the change in time. And that would be 4 minus 3. We need to be careful to do the 4 first, since we're finding the change from 360 to 480. So we want to stay consistent. The change from 60 to 80 is positive 20, and from 3 to 4 is positive 1. If you were to switch up the 3 and the 4, you'd be finding the change going in this direction and then going that way, which isn't consistent. Okay, so now from here we simplify and look what you get. You get 20 over 1, the exact same answer we got there. So two different ways of arriving at the rate of change. This, I think, really shows that you have a rate, the division, of two changes. It's beautiful, peeps. Some teachers even, they're going to call that slope. More on that in the not too distant future. Slope, rate of change, you're going to find out it's all the same thing. Okay, if you're really, really good on that problem, awesome. I would suggest listening a little longer. I know this video's a little lengthier than some, but it's still short. It's not bad. It's a great investment of your time. I would really urge you to watch me do this one and listen carefully. This is a little different in that the differences in the values are not going to be consistent like they were in this problem. But no sweat, we can still find the rate of change. Let's do it. So looking at this problem, we are going to find the differences between each of the x values. To go from -3 to -1, we have risen 2. So we have gone up 2. And typically, these values go up in the x column. However, the y values can go up or down. Now, from -1 to 0, 0 minus a -1 is a change of 1. From 0 to 4, we go up by 4. And from 4 to 5, we go up by 1, or 1. Now, you could have done that with subtraction as well, like I showed you previously in this last problem. Now, the y values, to go from 1 to 7, we went up by 6. To go from 7 to 10, 10 minus 7, we went up by 3. From 10 to 22, we went up by 12, or 22 minus 10. And then to go from 22 to 25, we went up by 3. Beautiful. You might look at these numbers and think, well, those aren't consistent. No, but the rate of change will end up being the same. Check this out. If we find the rate of change between these two numbers, you see how for the increase of the x value of 2, we go up by 6. That's 6 to 2. I'm going to put that right over here. So for every 6 increase in the y direction, we go up 2 in the x direction. That simplifies to 3 over 1. Then if we look at the rate of change here, right, we've gone up 3 for every 1. Oh, so that's 3 for every 1. Same thing. And then here, between 0, 10 and 422, we've gone up 12 and over 4. I should say up 12 in the y direction, up 4 in the x direction, which is 3 over 1. And finally, in this last one, between 422 and 525, we've gone up 3 in the y direction and up 1 in the x direction. So the rate of change actually is the same for all of these data points. It's all for every change of y 3, we go change of x 1. Again, just to reiterate, you could have found the rate of change using subtraction. It does not matter which points we use or which data points. So I'm going to use 0, 10, and 422. So to find the difference here and the rate of those changes, the rate of the differences, I will do the change of y, which is 22 minus 10. That right there represents, again, how much we have changed from 10 to 22. We will put that over the change of x, which is 4 minus 0. Very cool. And we'll simplify, we'll get 12 over 4, which is 3 over 1, which is the exact rate of change we got when we did it shorthand notation, just seeing how much we go up by. One thing to point out is it does not matter the direction you go. I could have gone with these numbers and I could have done 10 minus 22, but then I would have had to have stayed with that direction. So 22 to 10 is a minus 12, and then 4 to 0 is a minus 4. So I'd have to pair up the 0 with the data point 10, the y value it corresponds to. That would get me negative 12 over negative 4, which is equal to positive 3 over 1. So you still get that same rate of change. Very awesome stuff, peeps. So the rate of change, again, is the comparison of changes, differences, of this column's values to this column's. The reason why we go with the right column to the left column is typically the left column is our input, the right column is our output. And just like with the order of operations in math, we've established this as the way that we go with the change of the outputs over the change of the inputs. In this case, it's the change of the y over the change of the x. That's enough math yapping for me in this video. Rate of change is huge. And I always say, now go rock that math. But here, literally, go rate of change, rock the rock.